So I think now we're going to set up for the next part of the next session in the morning, and that's a paper from Chris Rees, who is the Leakage Strategy Manager from Welsh Water, Dŵr Cymru, God's own country, I would say, as a proud Welshman, and Steve Toombs, who's the Executive Director of Invenio. And you can see them already on the screen there. So hopefully we're all connected up. And we'll crack on. Over to you, gents.
Thanks very much, Bob. Just do a quick sound check. Everybody, can you hear me okay?
Yep. Loud and clear.
Good stuff. Good pronunciation of Dŵr there as well, Bob. So good morning. So yeah, Chris Rees, Leakage Strategy Manager at Welsh Water. So I'm delighted to be able to speak again today on day 2 of what has been an excellent conference so far. Today I'm going to give a brief introduction to Project Cartref, our customer-side leakage and water efficiency program for AMP7, before handing over to Steve from Invenio to kind of delve into the technology deployed and some of the findings. Next slide there, please, Steve. I feel like Chris Whitty. So firstly, I just wanted to touch upon our unique not-for-profit, not-for-shareholder profit business ownership model, which I believe is a key facilitator in the success of this project. It really does allow us to put our customers at the very heart of our vision, and that vision is to earn the trust of the customers every day. The trust developed with our customers has allowed us to develop our ambitious customer-side leakage and water efficiency program, Project Cartref. Cartref meaning home in the Welsh language. So next slide there, please, Steve. So we split our approach, proactive approach to leakage detection between customer-side losses and distribution leakage. So this is owing to the very different skill sets and technologies required in order to tackle these problems and to also ensure we get the right level of focus on these issues. So we had some very much frontier projects, I guess, yesterday afternoon in locating distribution leakage. And I look forward to following up on some of them, actually. So, but today we will focus on the customer side losses. So I think that fits quite nicely. So next slide there, please, Steve. So where's the leakage? So this slide shows our current estimate of distribution and customer side leakage. And as technology and meter penetration develops, so does our understanding of where the leakage is. So over the last few years, we've undertook extensive studies with our partner Invenio, which really have redefined their understanding of customer side losses and increased their estimates to almost 25% of total losses. And I think that really emphasizes the importance of having this dedicated program. It's reduced the quantity of water that we estimate as background losses. And I'm sure as technology and smart metering and as such develops further, and you know, some of the frontier work that Alex and Jamie just showed there advances, we can really redefine what background losses actually are. And I'm sure this is going to be the subject of much research over the coming years. So we can move on to the next slide there, please, Steve. Project Cartref, it's a proactive program targeting problematic DMAs with high ILI. They are primarily largely densely populated and usually made up of at-risk leakage property types based upon the age and supply pipe material. So we've committed to survey over 200,000 homes over the next 5 years and undertake tens of thousands of home visits off the back of them. And it's at the home visit where we can repair the leaks, whilst also undertaking the opportunity to install a wide selection of water efficiency devices. And in addition to that, it's a fantastic opportunity really to have a conversation with the customer regarding their water use. We can provide information on other business initiatives as well, such as our meter options, and linking into sort of retail and waste strategies to help promote affordability tariffs, priority services, and Stop the Block campaign. Next slide, please, Steve. So, animations and slides.
The slides don't appear to be updating at the moment, just to let you know. I've still got the where's the leakage slide up on my screen.
Okay, I can see a Project Cartref slide with the 5 steps.
It's probably a problem with me then. Yeah, it's okay.
Is that what you can see as well, Steve?
I can see the same as you. The 5 steps, Project Cartref.
Okay.
Okay. Oh, Jamie's on the Cartref slide too. Excellent. Thank you, Jamie. This is interaction as we need it. Oh, Joe Parker as well. So I'm actually going to hand over at this point because the going's getting tough. So yeah, Steve's going to speak about step 2 and step 3 in a little bit more detail. Over to you, Steve.
Thanks, Chris. All right, next slide. Can you put the next slide on, please? Okay, so I am going to cover the that's at step 2 and step 3 of that 5-step process, and really concentrating on our use of stopwatch surveys as part of Cartref. Next slide. Next slide. Right. So in Venio Systems, it's been, well, we've been established for 6 years now, nearly 6 years, and we've really, the basis of the business has been pioneering the use of temperature measurements in the distribution system, and both on customer supplies, which is what I'm going to be talking about, but also further up in the distribution and trunk main systems as well. Next slide. So, so we've been involved with Welsh Water while they and us have been developing the Cartref concept almost since the beginning of Venio Systems, and we've got to the point now of when we're working with Welsh Water on Cartref over the whole of the next AMP7 or the current AMP7 business plan period. Next slide. And this is a sort of summary of the Cartref, or our bit of the Cartref process. So there's the area selection, an acoustic logging and leak detection stage in the distribution system, and then moving on to doing a stopwatch survey, which is a survey to find customer side losses, which is both plumbing losses and customer side leaks, underground supply pipe leaks, as well as identifying night use. So there's a whole set of benefits that come out of doing that stopwatch survey, which then inform further decisions and also identify real leaks that the Welsh Water can then repair. Next slide. So I just wanted to describe quickly what stopwatch does. It's a high precision temperature measurements on external stop taps, and we use the data that we get from that temperature measurement to identify customer use and to identify and quantify leaks. So the logger, which is a picture on the right hand side there, goes on the stop tap, which goes where at the junction between the communication pipe and the underground supply pipe, mainly on domestic properties. Next slide. So this is a representation of how of what we do, and how the temperature, how we use the temperature measurements. So this is a representation of a boundary box with a communication pipe coming in on one side, underground supply pipe going off on the other side to the house. So the little picture on the right hand side indicates the pattern of water use by the customer, and the picture on the left hand side indicates the little graph on the left hand side indicates the pattern of temperature in the water main. So you get this characteristic diurnal pattern of temperature that varies, and that graph shows it over 2 days. So when water's used by the customer, or water's drawn through the communication pipe, and that as that water travels along the communication pipe, there's a transfer of heat between the pipe and the surroundings to the pipe and the water, and that produces a temperature change which you can measure in the stop tap. So we can interpret the temperature that you see in that middle graph, and to work out what the customer demand is, using effectively a hydraulic and thermal and hydraulic model of that set of pipes. Next slide. So if you had a short intermittent flow, so someone running water for maybe 30 seconds at 6 liters a minute, so maybe washing their hands, you get the green line indicates that flow, which is you can see on the right hand side of the graph, and the black line shows the temperature response that you get at the stop tap. So this is a modeled result. So you can use that temperature to identify that use event has happened, and also to quantify it. Next slide. But when you get a leak that's a continuous flow past that point, which might be due to a leaking toilet or a dripping tap or an underground supply pipe leak, you get a very distinctive change in that temperature profile, which is quite easy to identify. And so we can use that to identify that the leak's going on, and that change in the profile is also dependent on the flow rate of that leak as well. So we can identify to some extent what the flow rate of the leak is as well. Next slide. So we've done a lot of verification of our results against metering. This is just one example of where you can see that the black dots are average daily consumption for individual properties, and it's comparing the metered average daily flow to our calculated average daily flow, and you can see you get a really good correlation between those two. Next slide. Okay, so this is one example of the temperature data that we get. This is data over 7 days for an individual external boundary box. So this is an unmeasured customer supply, and you can see that you get a set of peaks and troughs corresponding to customer use, and then during the night, when there's not much use going on, in this particular case, you get a very flat profile of temperature. So we can interpret that data to calculate how much water that customer is using. Next slide, please. Okay, so this is another odd example. Between 2 and 3% of the customers that we survey, we get this kind of result from. So, and you can see that every 10 minutes or so for the whole of this log, or for most of this logging period, you get regular peaks in temperature, and this corresponds to a toilet where there's a leak out of the bottom of the toilet system, which is being fed periodically by the opening and closing of the inlet valve to the toilet system. So a reasonably common cause of leaks, and we see this quite a lot. Next slide, please. And then this is the kind of temperature profile we get when there's a significant leak. I think this one is something around 200 litres an hour. So we can identify that as being very different, and we can highlight those as being leaks that need to be followed up to resolve them. Next slide, please. So in the Cartref process, we survey whole DMAs. So we put a stopwatch logger on each stop tap in the DMA, and we end up with hundreds or maybe thousands of individual temperature profiles. So I've got two examples on the left-hand side. We process those to calculate the flow rates that going past each stop tap, and then we can use that to identify individual leaks which need resolving, but we can also add all that data up to get a diurnal profile for all the properties in that DMA. So, which is indicated in one example on the right-hand side. So we may end up with, I don't know, 1,000, 1,500 individual surveys that go into this profile. Next slide, please. So this is one example of the results we got. So the orange line here is the DMA meter flow, and the blue line is the sum of all the stopwatch survey results. The picture on the left shows that each green dot is each property in that DMA that's been surveyed. This is a DMA in Newport, and we identified a set of leaks, and we've also identified a set of individual properties from the stopwatch data, which are high users, which can then be used as part of the focus for water efficiency program. But you can see that those blue and red lines, although they match each other pretty well, the orange line is moved up, and that's because there is leakage in that DMA which is not going through the stop taps. So in this case we've got some distribution leakage as well as getting leakage in the as well as having customer side leakage.
If we hurry you up a bit, Steve, because there's a lot of questions out there waiting for you.
Okay, right. Next slide. Next slide, please. Okay, so this is a sort of typical result we get, and I just wanted to highlight that that in the sort of traditional approach to this, you would identify this diurnal pattern that you get on the left. So this is a typical day out of that 14-day period. That typical pattern, you'd interpret it as 2.3 litres an hour of night use, about 1 litre an hour of customer side losses, and then the rest of it would be distribution system losses, which you would then go and look for. The stopwatch results shows that actually there's a lot more night use in this particular DMA. There's quite a lot of customer side losses, and so the distribution system losses are actually less significant. You can also see that we get a really good match between the average daily DMA flow and the sum of the stopwatch data. Next slide, please. This is another example. So it's a DMA. It's actually on the banks of the Severn estuary. In this case, we've identified that actually there's very, very little distribution losses in the system, in spite of the relatively high minimum night flow. And there's actually a lot of customer side losses and quite significant night use as well, which is so that would drive you to do something completely different with this DMA compared to what you would do if you thought it was all distribution system losses just from the DMA data. Next slide, please. So if we take all the distribution system, all of those stopwatch surveys, we can use it to look at the distribution of unmeasured household consumption, and also in this case unmeasured household or all household night use. I just wanted to illustrate that there's an incredibly long tail of night use, and that very long tail of night use, where you've got quite rare but really important but really significant customer night users, produces a very big variation in night use in actual night use between DMAs. Next slide, please.
Should we pick up on some of the questions, Steve? Just mindful of time.
Okay. So just wanted to say that produces a very wide distribution of losses. So yes, okay, let's pick some questions up.
Okay, so the first one here is from Louis, who said, can you use, so brief answers, please, because there's a lot of questions.
Okay, okay.
You need to be quick fire on this. So can you use these temperature loggers to predict burst outbreaks in the water company network?
Yes.
Yeah, not that brief.
Yes. So I think there's two things we can do. One of them is to measure the temperature of the water in the distribution system and use that to predict where leaks are likely to happen. The other one is that we can use temperature measurements in the distribution system to identify in which areas of a DMA that a leak has occurred, in a very similar way to that you can do with pressure.
I think that's picked up with the street level sensing project, which is ongoing with probably 9 or 10 water companies at the moment.
Okay, so what is this impacting? Paul's question here, Paul Parr. How is this impacting the sort of people that we're using now to follow up on this data? Are we? I think he's effectively saying, are we using leakage technicians, or are they more like plumbers, or something in the middle, perhaps?
Yeah,
I think, Chris, that's with you.
Yeah, morning, Paul. But in short, we've kind of recruited from our leakage detection resource because what we found was we had some skilled plumbers in there. So I guess it's very much linked the two sorts of industries over the years. So we found that we had some already qualified plumbers within our teams. So we've kind of gone through a process of upskilling those, putting them through WaterSafe accreditation, so they are multi-skilled, and we kind of equip them with lots of different equipment at the moment. And we can't hide away from the fact that the lockdown restrictions have prevented us from entering homes. But we're hopeful once things open back up, then we can continue with the internal home visits and the installation of water efficient equipment and undertaking the internal repairs also. Okay,
there's a question from Joe here to you, Steve. How does the condition of the pipe affect thermal transfer in terms of old rotten galvanized iron pipes compared to newer pipes, even plastics?
Okay, you definitely get the clearest results on thin-walled metal pipes, but we can get results on on all the materials that we've come across. There are differences, but we can use the temperature data to understand what the effect of those differences is. So yes, the outside temperature does affect it, but we're correct for that. We take account of that.
Okay. And another question
is interesting
on the customer impact for you, perhaps, Chris. Did you get any hostility or any plans or any difficulty with customers, or did you get full cooperation?
I think it comes back to that trust piece at the start that I mentioned. We are a very well trusted business within Wales, and we've got a good relationship with the customers. We've actively promoted our not for shareholder profit status, and it's all kind of led to that trust. So what we're seeing is far higher appointment rates than what the similar kind of offerings with utilities would have. So we are managing to get through the door. There is some hostility with some customers, and you kind of get those non-engagers as well. And Steve's slides highlighted that distribution of customer use, and you see a very long tail on that, and they tend to be the non-engagers as well. So they are a challenge. We don't have a compulsory metering policy at the moment, so those customers do pose us with a challenge. But we've got a very strong comms team to sort of follow it up, and it kind of links into Michael's question there as well. Michael Wilmot just asking about the impact on the PCC ODI, and a large part of the Cartref program is part of our water efficiency program to target those high users and have almost street level comms campaigns and product offerings. So yeah, one of the big outputs of Project Cartref is our water efficiency campaign also.
Okay, I think we've answered one way or another most of those questions. Perhaps just one from my perspective. What is all of this doing to our understanding of background leakage and the assumptions that we've been making?
Okay, shall I answer that one? I think the more work we do, the more we realise that the outliers, the unusual customers have a really big effect on the overall assessment of consumption, but they tend to have been rejected or ignored rejected as outliers, as unlikely to be true.
Yeah.
Once you start including those, I think it explains a lot of what background leakage actually is. I think a lot of background leakage is actually consumption. It's really difficult to find it and detect it.
Yeah. And this is probably an area we need to do more research in, would you say, Steve and Chris? Yeah.
Oh, definitely. It's because if you start thinking that background leakage might actually be consumption, then it starts to explain a lot of the things, like the fact that in spite of the effort that was put in the UK on leakage management, we don't seem to be at the forefront when you measure actual leakage levels.
I think thinking about Jeremy's heat map from yesterday as well, I think we probably need to have something specific on background losses and a bit of an in-depth study as an industry into that and try and get a better understanding, because our leakage ambitions to 2050 mean we need to be below our background loss estimates. So clearly we need to have a better understanding of them.
Yeah, I would certainly agree with that. And I think over the years we've been through all of these various assumptions that we made all those years ago in the BABE software and so on. We've been collecting more data and verifying reservoir losses, trunk main losses, all those good things. Still need more, mind you, but it's improved certainly. But background losses is something probably we haven't done as much on as in other areas. So I would certainly support that view.
Yes.
I think we're time's up, unfortunately. We could carry on this discussion for some time, I'm sure. So it remains for me to thank Steve and Chris for another Really great and stimulating presentation, and thanks to everybody on the floor for their questions as well. Maybe Chris and Steve, there's some questions there that we may not have got round to, but I'm sure you can follow those up on the chat separately.
Absolutely, yeah. Thanks very much.
Great, thank you. A round of applause, virtual round of applause again. So well done to you both. Thank you.